All right, here we go. Once upon a time, there was a point A, right? So pretend you have some point A right here. Give me 2 shakes to just calibrate this thing. Yeah. I'm going to fast forward this part on the video. Sweet. All right. Once upon a time, there is a point A, and there's a line that goes through point A. Okay? There's some line that goes through point A, and it's in the direction of a vector B. So there's some vector B that's parallel to it. Point A goes in the same direction. It's not the same vector, though. Yay? R is a point on the line. So pretend this is R. Yay? Okay? And it's some scalar multiple of V. Well, I mean, you know. All right. So if we were to set the displacement vectors, you would have from the origin the vector A, true, and the vector R, right? And remember, R is some scalar multiple of V, so let's use lambda. Okay? So would you agree that the vector R is equal to AR, right? The vector, OR, I should say, which, as you recall, is the vector R minus the vector, OA minus AR, so OA plus AR, I should say, plus AR, right? And then just change it to simple form. You have A is plus lambda B. Yeah? Looks horrible. Not really. Here's the deal. You've seen this equation before in lines. Right? It's just switched around. It's y equals mx plus b. You see it? Yeah. Hang on for a second. All right. So if you think of it as a point slope formula, right? The slope is like the direction of the line. So in this case, this one, this B, like stands for the slope. It's kind of flipped around. It stands for the slope, and that would be the direction vector. And then the first one is the position vector. So in R equals A plus lambda B, this one is the position vector. And then the B is the direction vector, aka slope. Yay? And that's a vector equation of the line. Yeah? Does this look familiar? Am I getting close to where Metter was? Or should you go further still? Further still. Let's keep going. All right, here we go. So for example, here we go. Yeah. If you want to find the vector equation of a line through 2, -1 with a gradient of 3/4, and then deduce the Cartesian equation. So we can do point slope and get the Cartesian equation, which is y equals mx plus b. That's easy, but let's deduce it from the vector equation. Yay? All right, here we go. So step 1, let's get the vector equation. We're going to do that first. Here we go. I don't even know why that's not... Or there's a box around there. All right, there you go. Yep, okay. So step 1, we're going to do the vector equation for it. All right, so if you think of the gradient, right, gradient's y over x, isn't it? Yay. So the direction vector, go ahead. What is it? 4, 3. Excellent. Position vector, what's it going through? Yeah, 2, -1. Yeah, -1. So putting all this together, the vector equation is going to be the position vector. So 2, -1 plus lambda 4, 3. Yay? So there's the vector equation right here. That's the vector equation. Yay? Now, and to do it the long hard way, because it's, you know, IB, to find the Cartesian part from the vector equation. All right, so the second half of this, if you let R represent xy, you would have xy is equal to 2, -1 plus lambda 4, 3. Truth? Okay. And that would break it up into two equations. So you got x equals 2 plus lambda 4, and y is equal to -1 plus, 4 lambda, 3 lambda. That might be easier to read. 4 lambda, 3 lambda. Yay? Solving for lambda, you'd have x minus 2 over 4 equals lambda. And over here, y plus 1 over 3 equals lambda. So would you agree that x minus 2 over 4 is equal to y plus 1 over 3? Yeah? Cross multiplying, blah, blah, blah. You got 3x minus 6 is equal to 4y plus 4. And then just subtract the 4 from the other side. So you'd have 3y minus 10 is equal to 4y. And that is a Cartesian. You could divide by 4 if you want. 3x. Thanks, Matthew. Yeah. You could divide by 4 if you want, but if you just leave it as, you know, whole numbers, it'd be good to go. So this is the Cartesian. In other words, y equals m plus b. All right, equation. Yay, she did this already. Excellent. Moving forward. Here we go. Okay. Find a vector equation for the line parallel to 3, 1. Oh, sorry, that goes to 3, 1 parallel to the y-axis. So we need a point, we need a slope. Okay? What do we have? It's undefined. Yeah. So would you say that, well, yeah. So what, we have the position vector, don't we? Yeah. Is 3, 1, right? And then the direction vector is just j. True? Yeah. Is j, since it's parallel to y-axis. Are there two r's? P-R-L, parallel. Ah! Because the l's are parallel to y-axis. What's up? So much energy. Ouch. All right. Here we go. And if it's j, I mean, if we kept it in this form, j would be 0, 1, right? Is that right? 0, 1? Because there's no 1 over, no, 1, 0. If it's j, I is 1, 0, j is 0, 1. I, j, k. So it'd be 0, 1. Is that right? Okay. All right. So, well, how about this? Since we have this in j, isn't that the same thing as 3i plus j? True? Yay. Okay, so our vector equation is the position vector, so 3i plus j plus lambda j. Just to keep it ijk. Yeah? Because it's parallel to the y-axis, so it's the y value. So x is I, y is j. Yay? Yay. Okay. And then would you agree that r could also be written as xj plus yj? This stretch? Okay. 3i plus j plus lambda j. I didn't change anything on that side. Okay? And if you were to equate the components, the x would be equal to 3. So you have x is equal to 3, and y is equal to 1 plus lambda, right? Since it's parallel to the y-axis, we don't need to solve this. It's already solved. Which is the answer? Parallel to y-axis. So what's the solution? Y equals 3. Yeah. So that's the solution right there, because it's parallel to y-axis. AKA vertical. Right? So we don't have to solve for the y part at all, because it's not part of the equation. Yes, love? Mm-hmm. Ah, thank you. All right. So you know what am I trying to say? Is it the unit vectors? Right? So I is 1, 0, and j is 0, 1, if you're talking about x's and y's. Because there would be a component in the x, but nothing in the y for I, and then 0. Yeah. Yay? Yeah. So if you think about this one, it's lambda 0i plus 1j. So just simplify it as j. Good times. All right, here we go. Moving forward. Going too fast, too slow, just right? Just right. All right, let's keep going. Here we go. Whew. Lee, if you're watching this, man. Here we go. Find the points in common to the pairs of lines. All right, so here we go. If you were to, if you were to equate those two things together, you would get, the first one, you would get r is equal to 1 plus lambda, right? And the second one, you'd get 2 plus lambda. Okay? And the second one, you would get r is equal to 3 plus mu, and then negative 2 plus 4 mu. True. Okay. So just equating the parts, the x's would equal each other, so there's a top. So you would get 1 plus lambda is equal to 3 plus mu. And then the second part would be 2 plus lambda is equal to negative 2 plus 4 mu. Yes? Okay. Solve for mu. All right, let's do this. Well, you solve for mu and lambda, but should we try a system? Let's try a system. Just to, bring it together. All right, here we go. Full circle, full circle. Here we go. I'm gonna put m and lambda and mu at the same in the same spot. So lambda minus mu is equal to 2. Okay, and then lambda minus 4 mu is equal to negative 4. It's true. Yay. So using our handy dandy row reduction, if I just take row 2 minus row 1, you would have lambda minus mu equals 2, and then negative 4 minus, so negative 3 is equal to negative 6. Okay? And so this tells you that mu is equal to 2, and if you plug in 2 here, that makes lambda equal to 4. Ta-da! Yay? Okay, so that's the solution for lambda and mu, but it doesn't tell you what point. Plug it back in. does it matter which one you plug it back into? Heavens no. Yeah. So just plug back, hello, in to one of the equation. One equation. There we go. I'll take the first one. Yay. So it's 1 plus 4 and then 2 plus 4, which gives you 5, 6. Yay. So therefore, the point in common is going to be 5, 6. Whew, that was a lot of work to set two things against each other. Oh. All right, here we go. Number 4 is the same thing, where it's a two-parter, right? So if you take a look at it, it says show that those two lines are A, parallel, and then B, find the vector equation for the line parallel through 1. So let's start with parallel. Right? Let's do the parallel part. How are they parallel? Well, what are their slopes? Yeah, they're direction vectors, right? So the first one has a direction vector of -1, or direction vector. Position vector? Direction vector. Are -I plus 3j and 2I minus 6j. Right? How do you know they're parallel? Yeah, this one is just a scalar of this, right? So note that 2I minus 6j is just a scalar because it's just -2 times -1I plus 3j. Right? Therefore, they are scalar multiples. And so they are parallel. Yeah, that was the easy part. Let's do the other one. Here we go. Part 2. Line through 1, 1. So this is the second part. Oh, that's 2. Okay. We have 1, 1. 1, 1 is the position vector. So we know the position vector is I plus j because it's 1, 1. Right? Because it goes to the point 1, 1. Yeah? Okay, so an equation for a line parallel, for a parallel line through 1, 1 is, you could pick either one of the r's, because it'd be parallel to, because those lines are parallel, so pick one of them. Do you want the lambda or the mu? Let's do lambda, okay? So an equation parallel, for the line parallel through 1, 1 is, just pick one of the equations. It'd be R. Lee! You're on YouTube. 1 plus J. Thank you, sir. Grab the notes. Here. Yes, sir. How are you this morning? Good, good. Yeah, so the position vector would be I plus j plus lambda -I plus 3j. Right? Or you could have used the mu one. Okay? So basically, for all the two-dimensional vectors, direction vector, position vector, aka slope and y-intercept. Yeah? Yay! Yay! All right, let's go backwards. If I gave you the Cartesian, can you tell me the vector equation? Okay. position vector, direction vector. What do you want to give me first? Position vector. What's the position vector? Is 0, 1 on the line? No. 5, 1 is on the line?
I want to keep the direction vector first, because it's just the slope. So why did you say position?
Just give me a point on line. So, Matt, pick an X. Like, give me an X. 2. All right. Okay. So if you plug in 2 for X, right, going to point 2, what would the Y be?
-3/5.
Okay. So I mean, we can do that. Let's pick a bigger number so it's not a thing. How about this? Why don't we do like a multiple of 5? Or maybe is it 27? Oh wait, instead of 2, how would we do -2? So that way when we add to the other side, it'd be 5. Right. Okay. Okay. So the point -2, 1 is on the line. So the position vector would be -2, 1. Right? True? Okay, so we have the position vector, we need the direction vector. Yes, very good. The gradient, well, we could have. We totally could have. Right? The gradient is 5 over -2. True? Because y equals mx plus b, you would just solve for y, and so on. Therefore, the direction vector is going to be 5. Oh, I keep doing it. Woo! I flipped it.
Yeah, you flipped it. Because the gradient is -2/5.
-2 over 5. Whoops. Okay. -2 over 5, so it's 5 -2. Truth. Okay. Okay. Therefore, the one possible equation is R is, what was the direction again? Is it -2, 1 plus lambda 5 -2? Joy. Vector equation. Especially, I hate vectors. I hate them, I hate them, I hate them. All right. Yay? Yay. Well, when he does, I'm sure it'll be a lovely time. Do you want him to come in right now? We're like on a roll. Oh, yeah, he said he's going to put the fear of God in you. I'm like, really? There's 7 IB higher level seniors. But okay, okay, okay.
Last time I was in his office, it wasn't exactly.
Oh, that. Well, Alejandro, just sink into the crowd. And Snoopy. All right, here we go. You can do almost everything with a 3D vector that you can with a 2D, except the idea of slope. There's no slope out there, right? So that doesn't carry over, but you still need a direction. All right. Also note that 3D lines that are not parallel but don't meet are called skew. Very nice. Yeah. Skew lines. Skew lines. Okay. So here we go. Points A and B have coordinates blah and blah. Find the vector equation of line AB. Joy. Well, okay, nice. We know that AB is vector B minus vector A. So smart, so smart. So -291 minus -534 is like 3, 6, -3. Notice all of that can be reduced, so there's a scalar, which is 3. So it's just 3 and then 1, 2, -1. So that 1, 2, negative 1 becomes our, no, is that the position vector? Yeah? Okay. Yeah, so we have a position vector of 1, 2, negative 1. Okay. Is that the direction vector? Yes. The direction vector, I have them all mixed up on here. Yeah, that's the direction vector. Thank you, sir. Yeah. This is going to mess me up. Here we go. Direction vector. You're right. And since the vector goes through any one of those points, let's pick the first one. Let's pick the first one. So, a vector equation could be 5, negative 5, 3, 4, plus lambda 1, 2, negative 1. Joy. That's good. All right. Now we're coming on to some of the questions that are going to be on your take-home quiz today. What? Yeah. Okay. All right. Here we go. Too fast? Too slow? We good? We good. Yeah. Remember, I try to give you at least one quiz a week. If it's at the end of the week, then it's a take-home quiz. Yay? Okay. Okay. Here we go. Find the point of intersection, if there is one, of the line. So this is the frustrating part. There may or may not be one. Oh well. Okay. Yeah. So since those two lines intersect, set them equal to each other. So would you agree that 1 plus 2 lambda, 4 minus 3 lambda, and negative 2 plus lambda is going to equate to 4 minus mu, 2 plus 4 mu, and 4 plus 5 mu. True? Okay, here we go. So, 1 plus 2 lambda will equal 4 minus mu, and then 4 minus 3 lambda equals 2 plus 4 mu, and then negative 2 plus lambda equals, did I get that right? Negative 2 plus lambda, yeah, equals 4 plus 5 mu. And then putting the lambdas and mu's together, 2 lambda plus mu equals, yeah. Well, how about we just move the lambda on this side? So 3 lambda plus 4 mu equals, move to the other side 2. Yep, and then lambda minus 5 mu equals 6. You're correct, sir. Since there are only 2 variables, you only need to solve 2 equations at a time. So let's solve the first 2. Yeah? So what you want to do? So 2 lambda plus mu equals 3, and then 3 lambda plus 4 mu equals 2. What's up? There's a reason. There's a reason. I got you. Yeah, the hint was if there is one. All right, here we go. This could have also been done with just like substitution. You solve for some lambda and put it in. But let's do, row reduction. How about row 2 minus 4 row 1? Yeah, because there's a single lambda right there, a single mu right there. Yay. So that gives you 2 lambda plus mu equals 3. And at the bottom, 3 minus 8 is negative 5. That gets rid of the mu, and then 2 minus 12. Is that right? Oh, that's supposed to be a negative 2. Yeah, it's supposed to be -2. Whoopsies. There you go. That's a -2, so this is -2. That's okay. -2 minus 12.
No, it's supposed to be positive because we flipped the.
Oh, we did flip it around.
I think that.
Yeah, no, that's right. That's right. Does mu equal, mu doesn't equal, did I miss anything else? 2, so this is supposed to be a 2, because mu is not supposed to be, yeah, okay. What did I do wrong? Equals 2. Yes. All right, and the bottom one is 6, nice. 3 plus 4 equals 2, excellent. All right. 3 minus 8 is -5. 4 minus 4 is 0. 2. You want to do that? Let's do it. Okay, I like it. I like it. How about 2R3? No, 2R2 minus 3R1. Yay? Okay. So that gets rid of the lambdas. True? So 8 minus 3, it's still 5, isn't it? 4 minus 9 is 5. That's better. -5. There you go. Good suggestion. So mu is equal to -1. And if you plug that into here, divided by 2, lambda would equal 2. Right? But since there's 3 equations, you need to plug it into the third. All right. The third equation goes lambda minus 5 mu is equal to 6. So is that a true statement? 2 minus 5 times -1 is not equal to 6. That's true. Therefore, the lines, what is it asking? Yeah, so therefore the lines do not intersect. Right? One of those lines is skewed to the other lines, or they're just, yeah, they're skewed to the other lines. They may or may not, they may intersect with one of them, but not the other. Joy? Joy. Okay. Did Meta go over the Cartesian equation for 3Ds? Maybe? Let's see if this is familiar. That would be nice. Yeah, so you can see how far she went. That'd be great. Yeah. All right. Here we go. To the final equation line in 2D by eliminating the parameter, the same principle can be applied in 3D. So if you consider that equation, right, would you agree that since this is R, you would have X, Y, and Z is equal to -5 plus lambda, 3 plus 2 lambda, and 4 minus lambda. Yay? And from that, you can set up 3 different equations. So you've got X is equal to -5 plus lambda. You've got Y is equal to 3 plus 2 lambda. And Z is equal to 4 minus lambda. Okay? Solving for lambda in all of those cases, in the first one, you would get X plus 5 over 1. There's a reason I put it over 1. Y minus 3 over 2. And Z minus 4 over -1 to get lambda. Yay? Okay, so this is the vector form. This is the Cartesian form for 3D vectors. Think so. Z minus 4, and then to get rid of the negative, I just divide by -1, right? Cartesian. equations of the line. Thank you, sir. Is that the homework? Excellent. Appreciate it. Yep. Notice that all we did was manipulate where the numbers went. So in the y equals mx plus b stuff, the b just moved over, and then you divide it by the slope, by the intercept. No, slope. Right? So in general, if you have a line through ABC, and then the slope is ln of n, right? You would just take x minus a over L, which is y minus b over m, which is the same thing as z minus n over c. So, by the way, is z minus c over m. Nope, that confuses it. Here we go. All right. Delete. Let me try that again. Delete, delete, delete. Okay. X minus a over L, y minus b over m. Okay, does that look familiar? Yes? That is what we just did. Okay, excellent. Here we go. And last but not least, the example in the book went over how to derive this, but the moral of the story is when it comes to velocity and speed, the direction vector is the velocity. Yeah? The direction vector is a slope, so that's the velocity. And then the speed would just be the magnitude of the direction vector. So when you're looking at the vector equation, to pick out the velocity, it would be the direction vector. That's it. So what's the direction vector in the second one? Which one is it? Yeah, right there. Right? So the velocity would be 2, -2, and 1. Okay? And I just try to save room by not writing IJK. Blah. Right? And then last but not least, the speed would just be the magnitude of p, square root of 2 squared plus -2 squared plus 1 squared, which is 3. Right? Square root of 9 is 3. 4 plus 4 is 9, so 9, which is just 3. That's it. Yeah, you can take a look at how they derived it. It's not that big of a deal. The assignment tonight, if you go towards the, I think I have the wrong page actually. I take a look at it. 19. Yeah, the assignments tonight are the exam questions at the end of the unit, so it's going to contain some of the stuff from before, right? It's 5 questions. These are all ex-IB exam questions, and so is your homework quiz. I found 6 IB exam questions that, pertain to this. Questions, comments, concerns? You good? All right, you guys rock. Here we go. Pause.